I'm going to go through each of the 5 steps, and then we will do a lot of examples following our 5 steps. Step 1, we count the total valence electrons available. I like to think of this like a shared pool, such as poker chips in the middle of the table. I also like to think of it like a potluck dinner. Everyone brings something to share, and once it's brought in, it belongs to everybody. We need to figure out how many electrons each atom is bringing to the molecule, but once the electrons are there, they are distributed among all the atoms in a way that makes them all happy. If we are doing the Lewis structure of a cation, we subtract electrons for each positive charge. For example, if we were doing the ammonium ion, we would subtract 1 electron because it has a +1 charge. In our potluck analogy, it would be as if a bag of ice were dropped on the floor. It would no longer be available to share. If we are doing the Lewis structure of an anion, we add electrons for each negative charge. For example, if we were doing the structure of sulfate, we would add 2 electrons to our count. Those 2 electrons from the -2 charge of sulfate are just extra. They don't come in with any particular atom. Step 2. We draw a skeleton structure of the molecule or ion. I like to call this my stick figure, because it is just a rough sketch of the molecule, showing which atoms are connected to which other atoms. We start out with single bonds only. Do not draw in double or triple bonds unless you have to at the very end. As we make our rough sketch, we put the least electronegative atom in the center. Remember, the least electronegative atom will be the closest to the lower left part of the periodic table. Don't forget, hydrogen will never be the central atom, so it must be the least electronegative of the other atoms available. Step 3. Complete the octets of the terminal atoms. The terminal atoms are the ones on the outside of the molecule, not the central atom. You can think of a train terminus being the station at the end of the track. Each of the outside atoms needs to get a full octet, except for hydrogen, which only needs 2. We complete the octets of the terminal atoms first because they are more electronegative, so they want electrons more. Remember, the central atom is the least electronegative. Step 4. Place all remaining electrons on the central atom. We're going to have to do some counting here to see how many electrons are left in our shared pot. We can't use any more or any less than the total valence electrons. A lot of students end up with the wrong Lewis structures because they skip this step. This step is very important. Step 5. If the central atom still doesn't have an octet, pull 1 or more lone pairs of electrons from 1 or more terminal atoms towards the center to make double or triple bonds. This will give the central atom a full octet without changing the total number of electrons in the structure. Remember, this is the only step where you can make double or triple bonds, and you only do it if necessary. Let's look at an example. For SiH4, first we count the valence electrons. Silicon is in group 4A, so it has 4 valence electrons. Hydrogen is in group 1A, so it has 1 valence electron. There are 4 hydrogens, so there are 4 valence electrons from the hydrogens. 4 plus 4 gives us 8 electrons in our shared pot. Step 2. Draw the stick figure. Silicon must be in the center because hydrogen can never be the central atom. We connect silicon to the hydrogens with single bonds. Step 3. Complete the octets of the terminal atoms. Hydrogen already has the 2 that it wants, so we will not give it any lone pairs. Step 4. Place any remaining electrons on the central atom. Here's where we do our counting. We started with 8 electrons in our shared pot from step 1. We used 8 electrons making our stick figure with 4 single bonds. 8 minus 8 means we have 0 electrons left to put on our central atom. Step 5. Check the central atom for an octet and make double or triple bonds if necessary. Silicon has 8 electrons around it, so we don't need to do anything else for step number 5. In this case, our stick figure ended up being our final structure, but this is rare. The final structure will often have some important lone pairs or double or triple bonds that we will need to know about. So it is important to do all 5 steps every time. Let's do a Lewis structure of an ion. Step 1. We count the valence electrons. Carbon is in group 4A, so it gives us 4 electrons. Hydrogen is in group 1A, so it gives us 1 electron. Oxygen is in group 6A, and there are 2 of them, so we have 12 electrons from the oxygens. Don't forget to account for the charge. This ion has a -1 charge, which means it has 1 extra electron. We add that into our count. 4 plus 1 plus 12 plus 1 equals 18. Total electrons that must go into our structure. Step 2. Draw the stick figure. Carbon goes in the center because it is less electronegative than oxygen. Oxygen is farther right on the periodic table, and carbon is farther left. We connect the atoms with single bonds for starters. Step 3. Complete the octets of the terminal atoms. Each oxygen has 2 electrons from the single bond, so they each need 6 more electrons. Remember, we put electrons in pairs in our structures of molecules, so each electron gets 3 lone pairs. The hydrogen has the 2 it needs, so we leave it alone. Step 4. We do our counting and put whatever is left on the central atom. We started with 18 electrons in our pot. We used 6 making the single bonds in the stick figure, and another 12 making the lone pairs on the oxygens. That means we have 0 left over to put on the central atom. Therefore, we cannot put 2 dots on the carbon. We ran out of food at the potluck. Step 5. Check the central atom for an octet and make double or triple bonds if necessary. Carbon currently only has 6 electrons around it. We are going to have to make one of the oxygens share 2 more electrons with the carbon so that all atoms can have a full octet. We push the electrons from the lone pair into making another line in the bond between carbon and oxygen. That gives us a double bond. The oxygen had 8 electrons around it before, and it still has 8 electrons around it. We haven't hurt the oxygen, but now the carbon has a full octet, which it needs. We have one more step before our Lewis structure is complete. For ions, we must enclose the structure in brackets and include the charge. This is true whether it is a positive or negative ion. As long as there are dots in the structure somewhere, a bracket is needed before including the charge. Let's do a positive ion, NO+. Step 1. We count the valence electrons. Nitrogen gives us 5 and oxygen gives us 6, so that would be 11 electrons. However, the ion has a +1 charge, so it has lost an electron. That means we really only have 10 electrons to work with. Step 2. Draw the stick figure. We connect nitrogen and oxygen with a single bond. Step 3. Complete the octets of the terminal atoms. In this case, since the molecule only has 2 atoms, there isn't really a central terminal distinction. We are still going to follow the same principle, though, and complete the octet on the more electronegative atom first. In this case, that would be the oxygen, so we give it 3 lone pairs to complete its octet. Step 4. Place any remaining electrons on the central atom. We started with 10 in our pot. We used 2, making the single bond, and 6 more, giving oxygen its octet. That means there are 2 left to put on the nitrogen. Step 5. Check the central atom for an octet and make double or triple bonds if necessary. The nitrogen has only 4 electrons around it currently. It needs 8. That means it's going to need to share 4 more electrons. We pull 2 lone pairs from the oxygen towards the middle and turn the single bond into a triple bond. That still uses the same 10 electrons we had available, but now both atoms have a full octet. Again, since this is an ion, we finish up by putting brackets and the +1 charge. Let's do one more example before I give you a poll question. Step 1. Count the valence electrons. Oxygen has 6 since it's in group 6A, and each fluorine has 7 since fluorine is in group 7A. There are 2 fluorines for a total of 14 electrons from the fluorines. 6 plus 14 makes 20 total electrons. Step 2. Draw the stick figure. The oxygen goes in the middle because it is least electronegative. Also, a good rule of thumb is that if there are multiples of a particular type of atom, in this case there are 2 fluorines, they probably go on the outside. Step 3. Complete the octets of the terminal atoms. We give each fluorine 6 more electrons. Step 4. Place any remaining electrons on the central atom. We started with 20. We used 4 making the single bonds and 12 making the lone pairs on the fluorines. That means we have 4 left to put on the central atom. This is actually the first example where we had electrons left over to do that. We put them in pairs on the oxygen. Step 5. Check the central atom for octets. The oxygen now has a full octet, so we do not need to make double or triple bonds in this molecule. This molecule ends up similar to the water molecule, but it has fluorines instead of hydrogens. How many lone pairs does the central atom of nitrite contain? To answer this question, you will need to draw a proper Lewis structure. Be sure to follow your 5 steps. Is it A, 0, B, 1, C, 2, or D, 1 pair and 1 electron? The correct answer is B, 1. Please consult the poll question key for an explanation of this problem, including an image of the nitrite ion's Lewis structure. One thing to note is that we end up making a double bond with one of the oxygen atoms. They are both equivalent, so it doesn't matter which one we choose. The other oxygen is left with a single bond.